I'm going to be doing 4 separate physics experiments in this video. The first is with pennies. This is demonstrating how atoms are arranged in molecules. We have here 36 pennies arranged in a cubical shape where each penny is touching no more than 4 pennies at one time. And here we have the same number of pennies, 36 pennies, arranged in a hexagon shape. As you can see, they take up less space overall because they are more closely packed. A molecule that had a atomical structure like this would of course be more dense because it's the same mass in a smaller amount of space. Moving on to the second experiment, have a candle and 2 jars, a full liter jar and a half liter jar, and I will be showing that a candle, once the flame is lit, it will burn oxygen, and I'm going to see if it takes twice as long for the candle to burn out with the liter as it does for the half liter. So first, light the candle. I have a stopwatch here, and start. It was approximately 12 seconds for the candle to burn out with the amount of oxygen contained in a half liter. 12 seconds. I'll relight the candle. Start it over. And we'll see how long it takes. So it took about 30 seconds for the candle to go out in the liter jar. A little bit more than twice as long, but there are some variables that could account for that in terms of the way that I tip the jar on. This jar has a smaller mouth, this jar has a wider mouth, but it was approximately twice as long because the volume of oxygen that this jar can hold is twice as much as the jar this size can hold. The flame is the same size in both times, and so it burns the same amount of oxygen per second, so it makes sense that it would burn about twice as long with twice as much oxygen present. For our next experiment, we will go to the kitchen. I have a can with 3 holes in the side that I will be filling with water. And taking outside so as not to make a mess. When I remove my thumb from the holes, the water spurts out. I fill the can all the way almost up to the top, and so due to the height of the water present, the pressure is much greater. As you can see, as the water in the can decreases, the pressure significantly decreases because water pressure is correlates with the water depth. So the greater the water depth, the greater the water pressure. The lower depth as it is now, very, very low water pressure. For the second half of this experiment, we fill the can up again. This time, I'm going to drop the can and observe what happens to the water. Splashes on my leg. And as you can see, the water appeared to stop spurting out of the can as I dropped it. This is because